This will be a quick description of current dry gas seal technology and options and advantages for using externally pressurized gas bearing technology instead of aerodynamic technology. In this simplified compressor dry gas seal illustration, there is a suction process pressure of 2000 psi to be sealed. Because dynamic dry gas seals don't do well with fluids, the seal is protected by a buffer gas, which is often processed gas that has been dried and filtered. This buffer is injected at large flows, that is hundreds of cubic feet per minute, but small pressure differentials of only 5 to 10 psi over the process pressure. Most of this cleaning and drying effort is wasted as 99% of this gas flows back into the compressor process. But the real problem is poor reliability, as the fluids are still a major failure mode of dry gas seals. The fundamental reason for this is that the gas flow into the sealing gap is from the process side, from the high pressure to the low pressure side. With Newway's patented externally pressurized gas-bearing seals, the clean dry gas is injected directly between the seal faces, out of the face of a porous surface. So the highest pressure is always in the gap, with a small flow back to the process side and to the low pressure vent. The step change for reliability is that nothing flows across the seal faces. Only controlled, clean, dry gas is injected between the faces, and only a few cubic feet per minute are needed, not the few hundred cubic feet per minute needed for the conventional dry gas seal. Pressurized fluids can be directly at the seal edges, but will not get between the faces, as the higher pressure that exists there in the bearing gap will not let contaminants pass into the seal gap. With the Newway ventless seal, we have two separate inputs into a single seal face. This gives us a bi-gas capability, and we can segregate these gases in the single seal face, eliminating the need to send gases to flare or vent. The way this is done is on the outside edge, or on the process edge, we would put 2100 psi of process gas. Then, using a buffer gas, or nitrogen, we would inject that into the other side of the seal face, but at the same pressure. This would result in a higher flow to the low pressure side because the pressure is lower. But by adjusting the input pressures independently of each other, we can steer the high pressure point back and forth across the land. Using a gas detector, we can determine the exact balance point where all of the process gas goes back into the process, but none of the buffer gas will flow into the process. All of the buffer gas will flow back to atmosphere, but none of the process gas will go to atmosphere, essentially segregating the gases in a single seal face.